What's up, folks? Today we'll discuss LeetCode question number 2661. First, completely painted row or column. In this question, we are given an array which consists of a set of points which are present in a given matrix. So, as we go from left to right in the array, what we will do is we will keep painting that numbers, and we have to find the minimum index at which we get at least one row or one column entirely painted. For example, here we are given matrix 1 4 2 3, right? 1 4 2 3, and the array is given as 1 3 4 2. Okay, these are the set of points. Now what we will do is we will keep painting the cells in this given order. Like first we will paint 1, then 3, then 4, then 2. Okay, now as I paint 1, yes, it's done. Now if I paint 3, okay, this is good. Now if I paint 4, we have one row or one column painted, so I will return this index, which is 2. Similarly, here in this question we are given this array and a matrix here. Okay, now in the order of the elements given in the array, I will paint the cells. Okay, first I will paint 2. No rows or columns are painted currently. Same goes for 8, also for 7, but here as you can see 2 4 and 7 are painted, which form a row, which form a column. So I will return the index of 4, and it is 3. Okay, so how can I achieve this? So how can I solve this problem? Okay, what I can do is I can keep track of number of cells painted in each row or column. For example, if I have this example number 2, what I will do is I will keep count of number of cells painted in this column, in this column, and this column. Similarly, I will do this with the rows. Let's try to understand this with a diagram. Let's say I have this matrix. Okay, I have this matrix. Okay, and like this. Okay, and I have painted these are our columns. Okay, 0 1 2, same here. Okay, now if I have painted this, okay, so it means that in the rows, right, these are the rows and these are columns. Okay, if I have painted this one, okay, so number of cells painted in row 1 will be this, and same for column will be this. Now if I have painted this one, okay, 2, and right, so the row will be 2 and the column will be 3. Okay, if I have painted this, row will be 2 and the column will be 1. So here also we have 2, right? And I will keep doing this. Okay, like this. I will paint these, I will paint this, maybe this also. Now if I am painting this, okay, now as you can see we have this row complete. Now if I am having this row complete, what it will mean is the column, sorry, if I have this column complete, what will it mean is this, here it will show 4. Now this 4 is total number of rows. Okay, if I get this, like if I get number of rows in the column array equal, right, equal to the total rows, or vice versa, I will simply return that index. Okay, so let's try to implement this. What I first need to do is map every pair of coordinate with its value. Okay, why? Because here we have all the unique values. All the integers of array are unique, and all the integers of the matrix are unique. Okay, so which means that we have to make something like this. Let's say I have this matrix. Okay, okay, like something like this, and these are the coordinates. Okay, cool. Now if I have the value like 9 here, okay, so 9 will map to 1 comma 2. Okay, let's say we have 4 here, right? So 4 will be mapped like 3 comma 0, right? Now if I traverse through the array with using this map, I will increment the counter here, right? 1 and here, right? Here in the rows array and in the columns array. Let's say I have 7 here, right? So it will be 3 comma 3. Okay, now let's make all of these data structures. Okay, this will be the hash map that we just discussed. Map of quad. Okay, yep, we have done this. Okay, now I will iterate through the array. Also we have to make these this vectors, right? This and this. Let's make it row count, column count. Okay, this vector will be of the size number of rows, which is n, and initialize with 0. Same here, it will be initialized with m, which is number of columns. Okay, now I will increment the value, right? So for the current value at array, right, the row will be chord of array I. Like here we are fetching the coordinates of the point array I, and I want the first of it, right? Because I want the index of row, so dot first. Similarly for column. Okay, now row count. Now I will increment the row count. If row count of r is equal to m, or column count, I will return the index. If I right, and in the end let's just return a dummy value. Here we are not going to reach at any point, at any case. Okay, let's try to run. Oh, यहाँ पे it will be mad here. Okay, I'm sorry. Let's submit this. Oh, I mistakenly forgot to change this to R, to C. Yes, let's submit it. Yep, it got accepted. So this was the algorithm. Okay, let's summarize the approach once again with diagrams. Okay, so it's very easy to understand now. Let's say my array is like this. Okay, this is my array. Okay, and I have the indices like this, Okay, now for rows. Okay, now what I will do is, first I will let's say the values are like this. Okay, 7, 4, 6, 10. They may be placed anywhere in this matrix. Currently I don't know it. Okay, now as I go through the values of this array, I will keep coloring that cell. Let's say 7 is at 1 comma 1. Okay, and I color it. Okay, I have colored it, right? And so what we will do is, we will update this array, which is row, right? This rows has n columns, sorry, m cells, because this row has 1 2 3 4 cells, so it will be 4. Okay, now for here 0 1 2 3, we will increment here by 1. Same for column. We have 3 cells here because each column has 3 cells. Now for column also I will increment this 1 by 1, 0 1 2. We will increment this by 1. Now let's say this 4 is placed maybe here. Okay, and I color it. Now for 4, row will be 0, so I will increment this 1 here, and the column is 3, right? And the column is 3, right? But the index is 0, so I will increment this. And I just made a mistake. It will not be 1 here, it will be 3. Okay, for this row the column will be 3, so I will increment this. And for column the 0th row will be incremented. In the same case I will do for 6 also, right? And for 10 also, right? Let's say we, by doing this, we get any value here which is equal to the column or row, right? Let's say in a row we get any value equal to column, it will mean that the all the cell in that row, sorry, all the cells in that row are filled. If the value here is 4, which means that all the 4 cells here are filled. So if at any index I get this condition, I will return that index. Same case for column also. So that's pretty much it. Now let's discuss the time complexity in the code. So the time complexity will be, this part gives us of big of n square, big of n into m. This gives us big of n into m because the size of array is also n into m, and the inner part is uh, and the inner part is linear. So right, so the time complexity will be n into m, and the space complexity will also be n into m because these indices here are n into m, right? So that was pretty much it. I hope you like the approach. Thank you for watching. Please comment down below for any doubts or queries. Thank you.